Children who master the number line are at an enormous advantage to succeed in elementary mathematics. But what does mastering the number line really mean? It's easy to get young children to count vertically to a very high number, but it often comes out as a song or a chant. A common lower elementary school counting exercise is to count to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, count backwards, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, but it comes out like Elemental P does when students recite their alphabet. They're not concentrating on the individual unit, they're jumbling words together, and they're not seeing the relationship between them. We can take that counting exercise, and if we ask the child, what is 1 more than 6? If they need to start at 1 to access the answer, they don't have a deep understanding of the number line. 1, 2, 3, 4, 5, 6, 7. It's inefficient to count all to find that answer. Ask a child what's 1 less than 4, and if they need to start at 10 to access the answer, they don't have a comfort and a mastery of transitions between 4 up and 4 down. So if they say 10, 9, 8, 7, 6, 5, 4, 3, they're having to find themselves getting into that song or chant to access the answer. I think that when helping students gain mastery of the number line, it's important for us to redefine what mastery is. I believe that the most common mistakes educators make is introducing students to a large set of numbers too quickly. And so I always recommend that teachers begin trying to gain mastery of a small set of numbers, for instance, numbers to 5 before moving on to 6, or even numbers to 3 or 4 before moving on. Now, what does this mean? So it means that students can count linearly, vertically to that set of numbers, can count backwards to that set of within that set of numbers, but also to be able to change directions. So children who master the number line to 5 not only can count up and down to 5 and back to 0, but they can also change directions. For instance, 1, 2, 3, 2, 1, 2, 3, 4, 3, 4, 5, 4, 3, 4, 5, 4. When students are able to do it with that type of fluency, they're now ready to move on to another unit, numbers to 6. That, to me, holds much more value than counting to 20, 30, 40, or 50 in one direction and not being able to transition between them. This ability to change directions on the number line also has a lot of implications for being able to efficiently compute equations. So a child sees 7 minus 2. If they're able to comfortably start at 7 and count backwards 6, 5, they work much more efficiently than if they're not used to that type of exercise. They see 4 plus 3, 4, 5, 6, 7. They can efficiently solve. Linear counting with a defined start and end point. For instance, we're going to count by 1 to 10, doesn't force students to think 2 different ways on a number line. With unscripted changes of direction, students are constantly needing to think 2 ways on the number line. It takes more mental energy, it takes more concentration, but it leads to deeper understanding and learning later on. I believe in the same approach when counting with units bigger than 1. For instance, students who count by 2s, they're much better off being able to count 2s to 10 or 12 and be able to change direction forward and backward than they are to recite 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0. So when we have a defined start and end point, we are assigning an equal amount of importance to each transition because each number in the sequence is spoken in equal amount. But we know in math that's not true. The 5 to 6 transition to kindergartners is much more important than the 1 to 2 transition. Why? Because when we see 5, 6, 5, 6, we see 5 as a grouping of number. Open hand is 5. This serves as a gateway to access bigger numbers, the number line 6 to 10. 24 to 27 is not nearly as difficult of a Unit 3 transition as 9 to 12. Why? Because 9 to 12 crosses the 10, but 24 to 27 does not. And so when teachers guide students to make transitions on the number line, they're able to emphasize transitions that students need the most practice with. Throughout the set of videos, I will be emphasizing the more important and the more challenging transitions that students face. Each video in this series, or each unit in this series, is going to house the units within 10 multiples: 1 to 10, forward and backward; 2s to 20, forward and backward; 8s to 80, forward and backward. Why? I believe that when you keep the practice channeled and focused on the first 10 multiples, it leads to greater mastery, but also students are able to then take that understanding and apply it throughout the number system. The child that is comfortable with the number line from 1 to 10 forward and backward, and that knows, for instance, that 1 more than 6 is 7, can apply that to 1 more than 76 is 77. If we can count comfortably by 3s to 30 and are comfortable making the transition, for instance, 9, 12, and 18, 21, we can then count by 320 to 350, and the transitions, for instance, 329 to 332 or 338 to 341 will likely be a little bit easier because students can harken back to the foundational unit transitions that they learned early on. There are two people that I want to credit to for this project. Two people I want to credit for this project. The first is Robin Ramos, who was an incredible training mentor for me. She taught me concrete finger counting for lower grade students. You see a number and you say a number and you build a number line across their vision. The second person is Dr. Yoram Sagar, professor of mathematics at Florida Atlantic University. During the summer of 2006, he trained me in elementary math teaching methods and has been more instrumental in my growth as a teacher trainer and a math teacher than any other person. He invented a drill and inspired this series of videos through something that he calls happy fingers, which is counting up when a teacher points up, stopping and thinking when they do this, and pointing down when a teacher points down.